Error handling in our Android app was a complete chaos. Generic exceptions everywhere. 30 minutes wasted per bug trying to figure out what actually failed. Users seeing something went wrong for everything. Here's the pattern that fixed it. This was our typical repository code. Look at this getArticleById method. It returns nullable article, catches a generic exception, logs the error, and returns null. What actually failed here? Invalid ID, article not found, network error. We have no idea. Information is completely lost. Now look at the toggle like below it. If the article isn't found, we throw a generic exception with just a string message, article not found. No type information, no way to programmatically determine what went wrong. Just a string that someone has to parse somewhere up the chain. And here's what our view models looked like. Generic try-catch blocks everywhere. We try to get the article, and if anything goes wrong, we catch exception. But we have no idea what the actual problem was. Not found, network error, invalid ID, so we just show the user failed to load article, or parse the message from the exception and call it a day. Useless for both us and the user. This wasn't incompetence, it was reality. We started small. Couple of features where simple try-catch worked perfectly fine. Then we grew to a lot more features. No one stopped to say, hey, we need a proper system here. And when you're under deadline pressure to ship a new feature, you just throw an exception and move on. We all told ourselves, we'll fix error handling later. We did not fix it later. Let me quantify this for you. Each error-related bug took 30 to 45 minutes just to reproduce and identify which layer failed. Not fix it, just figure out what was broken. We had 4 developers. That's 10 to 12 hours per week burned on debugging. Code reviews became arguments. Should this return null or throw an exception? No one knew. And our users? They saw generic something went wrong message for everything. They couldn't tell if it was their internet connection or an actual bug. Support would contact us asking what the error meant, and we'd have to dig through logs to figure it out ourselves. If you're working on an Android app with more than 10 features, you're probably dealing with this exact problem right now. Your error handling is inconsistent. Debugging takes forever. And you know it needs fixing, but you don't know where to start. That's why we built this pattern. We implemented 3-layer error handling. Layer 1, repositories throw specific typed exceptions. Layer 2, use cases catch those exceptions and map them to domain failures. Layer 3, view models map failures to UI-specific error messages with proper formatting. The key insight here is this. Exceptions are for things that break. Failures are for things the app needs to handle. UI errors are for things users need to understand. Keep those concepts separate. Here's the transformation at the repository layer. Before, generic exception handling returns null for any reason, information gets lost. After, explicit validation and typed exceptions. If the ID is invalid, we throw invalid article ID exception. Specific exception for that specific problem. If we can't find the article, we throw article not found exception. No guessing required. And now the repository interface documents exactly what can go wrong. The @throws annotation tells anyone reading this code, this method throws either article not found exception or invalid article ID exception. Those are the only 2 failure cases. Clear contract. We define our custom exceptions at the repository level using a seal class. These are specific, typed exceptions for things that can go wrong in the data layer. These are throwable. They break the normal flow when something goes wrong. Notice some carry data. Common too long exception includes the max length, which we'll use later. Then we define failures for the domain layer. These aren't exceptions. They're data. They represent business failures that the app needs to handle gracefully. We have a base failure class for common errors like network issues, and feature-specific failures that extend it. For articles, we have article not found and invalid article ID failures. Same concepts as exceptions, but these are what flows through to the UI layer. This separation is the key. Exceptions at the data layer, failures at the domain layer. Notice failures can also carry data when needed. The use case sits in the middle and does the mapping. We use arrows either type here. It's like result but works with our custom failures. Left side is failure, right side is success. We wrap the repository call in a try-catch. If it succeeds, we return the article on the right side. If an exception is thrown, we catch it and map it to the appropriate failure. Article not found exception becomes article not found failure. Comment too long exception, with its max length parameter, becomes comment too long failure with the same parameter carried through. This mapping layer translates technical exceptions into domain concepts that the UI can understand, while preserving all the important data. Quick note, I'm using arrows either here because it handles custom failure types cleanly. If you're not using arrow, you can build a simple seal class for the same pattern. The concept is what matters, not the specific library. Here's where we complete the pattern. At the presentation layer, we create a UI era data class that's Android aware. It holds a string resource ID and a list of arguments for formatting. This is a pure data class, just a container for the information we need. This is the only place in our architecture that knows about r.string resources, keeping our domain layer completely platform agnostic. Then we add a format extension function to UI era. This is idiomatic Kotlin. Keep your data classes pure, add behavior through extensions. The function takes a context and uses it to get the localized string. If we have arguments, we pass them to format the string. If not, we just get the plain string. Now we map domain failures to UI errors. Simple failures like article not found map to a resource ID with no parameters. But look at the comment too long. It carries the max length from the exception all the way through, and we pass it as an argument to the UI era. Same with invalid sorting and the sort type. This lets us show user-specific actionable messages. Not just comment is too long, but comment is too long, maximum is 500 characters. Users know exactly what to fix. And here are the string resources with placeholders. The %d gets replaced with the actual max length value at runtime. The %s with a sort type. Clean separation. Domain layer has no idea about Android resources, and the UI layer handles all the formatting and localization. Finally, in the view model, we use either's fold method. Right side means success, update the state with the article, left side means failure. We map it to a UI error and store that in our state. Notice how clean this is. We're not doing string concatenation or hard-coding messages. We're just mapping typed failures to typed UI errors, and the framework handles the rest. And in our composable, we call format on the error, passing in the context. This is idiomatic Kotlin. We have a UI error, we want to format it, so we call the format method on it. The extension function gets the localized string with all the parameters filled in. It's simple, clean, and fully testable at every layer. We didn't bing bang this across the entire codebase. Week 1, I implemented it for our article feature. Week 2, I showed it to the team in code review. The response was immediate buy-in. Everyone could see how much clearer it was. Weeks 3 and 4, team members converted their own features. Each conversion took about 2 to 3 hours. By month 2, any new feature was required to use this pattern from day 1. We added it to our code review checklist. Are exceptions properly mapped to failures? Are failures properly mapped to UI errors? Check, done. 30 to 45 minutes per bug was cut down to 5 to 10 minutes. We know exactly what failed because the failure type tells us. Null pointer exceptions dropped 60% in 3 months. Explicit validation caught edge cases. What if this fails? On every method became, are exceptions mapped? One question, done. Support tickets asking, what does this error mean, dropped by 40%. Users could actually understand what went wrong. The codebase itself became self-documenting. New developers could look at the repository interface, see the @throws annotation, follow the mapping to failures, then to UI errors, and understand the complete error flow in minutes. No more hunting through code to understand error paths. Error handling needs architectural structure, not just handle errors properly. Different layers should care about different kinds of errors. Repositories care about what broke. Use cases care about domain failures. View models care about user-facing messages. Keep these concerns separate and pass data through each layer. So when should you use this? Well, you should use it when your app has 10 plus features and error handling consistency is becoming painful. You follow clean architecture or MVVM with a use case layer. You have multiple developers who need consistent patterns. You want specific testable localized error messages instead of generic ones. And your domain layer should be platform agnostic. On the other hand, you should not use this if your app is 5 screens or less. Just use simple try-catch. When you don't have a use case layer between repositories and view models. You're still in prototype phase? Premature structure kills velocity. And if all your errors are handled identically anyway. There are some red flags you should look out for. So if you have 50 plus different failure types for a single feature, you're being too granular. Group related failures. Article not found in cache. Article not found in database, article not found in API should just be article not found. If you're mapping exceptions to failures, but then immediately converting them back to exceptions, you're doing it wrong. Failures should flow through your domain as data, not as throwables. If your UI layer is catching and handling exceptions directly from repositories, You've skipped the use case layer and broken the architecture. Always go through the mapping layers. Error handling doesn't have to be chaos. Custom exceptions at the data layer, structured failures in the domain, clean UI error messages at the presentation layer. 3 layers, 3 responsibilities, 1 clean flow. We went from 30-minute debugging sessions to 5-minute fixes, and users finally understand what went wrong. Questions? Drop a comment, and thanks for watching.